for this question, we're looking at bounds, but we're dealing with bounds um, where you're not looking at the bound of a single number, you're looking at the bound of a group of numbers. Now, the gradient for the line LM, whenever you're working out the gradient, the easiest way to think of it is rise over run. So you've gone up 9.3 and across 5.4. But of course, 9.3 and 5.4 are only accurate to two significant figures. So the gradient is going to be given by, sorry, this could take a while, ln the rise over mn the run. Now, ln could be anywhere between 9.25 and 9.35. And mn could be anywhere between 5.35 and 5.45. Write 2 here so you don't think that I'm talking about minus in there. Subtracting. Okay, I hope you can read that. So ln is 9.3 to two significant figures, so it's the rise is anywhere between 9.25 and 9.35. mn, the run is anywhere between 5.35 and 5.45. So the question is, we want the upper bound for the gradient. So what that's asking for is the highest possible value of the gradient. Now, a common mistake for this is for people to do 9.3 divided by 5.4, get an answer, and then try and work out how that rounds up or down. That's not the way this works. When you're dealing with lots of numbers and upper bounds, you need to work out whether you need the largest value or the smallest value of any particular number to end up with the largest number overall. Now, excuse me, if we're trying to work out the largest possible value of 9.25 to 9.35 divided by a number which is between 5.35 and 5.45, what number are we going to pick for the top, and what number are we going to pick for the bottom? Well, the top number, the numerator, we want to be as big as possible. So if it's anywhere between 9.25 and 9.35, we're going to say that the rise is as big as it can possibly be, 9.35. And we're going to have a horrible time trying to write down the number 9.35. I hope that's good enough for you. And then we're going to divide it by, now to make the end result as big as possible, we want to divide by a number which is as small as possible. So we're going to pick 5.35, the smallest possible value for the run. And if you do 9.35 divided by 5.35, you will get the highest possible value of the gradient. So if we have any number between 9.25 to 9.35 on the top and any number between 5.35 and 5.45 on the bottom, we want to pick the largest possible number on the top and the smallest possible number on the bottom to end up with the upper bound for the gradient, the highest possible value overall. And that's the ultimate aim of this question. The answer you get is going to be somewhere in the order of 1.79 or something. I don't know exactly, but you should write down the full answer and not just round that